Okay, good morning or evening, gang. We're starting the chapter on organic chemistry now. I do want to mention before we even get going on this whole chapter that organic chemistry is it's very difficult in college. If you are thinking that you want to go into med school, vet school, anything that has to do with anything that would require you to do organic chemistry, be aware that there are a lot of big schools like U of M where organic is really, really tough. I would say in general in college, that second year chemistry class when you have to get into organic, it's a weeder class in a lot of cases for med school and vet school. So if you can take the one semester course that Mr. JV teaches here, you'll be finding it beneficial when you get there. Anything that you can do now to just to ready yourself for that class. And I mean, they go into quantum theory and organic. I mean, they really hit you with it and make it very difficult. So we're going to spend 2 weeks on it in here, and I'm going to teach you the basic structures of organic molecules and how to name them. A few simple reactions with them. There's way more than we'll have time for. We do a big chunk of the semester course that Mr. JV teaches, and we do it in 2 weeks in here. So we're going to be really cruising. Do the homework. Start it early. I'd say this weekend would be a good time to start. I'm not saying tonight you would have to start homework, but over the weekend I think that would be very helpful for you to get going on that. Just do the first few if you could, and you're going to find that the Zoomdalls write very tough problems, and you're going to have to kind of wrap your brain around those. As I present in here, I'm going to give you a system, and you say, oh, okay, I can do that. But then when it comes time to actually use that system and name compounds, some will be simple and then some will be pretty tough. So practice soon. Okay, and I would say too, while we're recording this one, it is helpful. I didn't think I told you this yesterday. I did it one of my hours. If you can do the problem, and leave yourself enough time to do problems in here twice before the quiz. September 16th is our first quiz. Doing the problems once through, you're going to find that you have to turn to the solutions manual just about every time to look up, okay, how did they do this one? I don't get that one. You use the solutions guide a lot. It does help you to go through a second time and try to do them. You're going to be much more well-versed. You'll know exactly what to do the second time through. You're going to go into that quiz on September 16th very confident and ready to go. If you've only gone through them one time, I'm not sure that you really have it at that point. That means being disciplined, starting early, and getting those problems done so that you have time to do them before the quiz a second time. Just as a suggestion, I think that you're going to find that to be helpful. All right, so organic chemistry. The first thing that I have here for you, and this looks like, oh my gosh, this is so much, but the very basics of organic chemistry go like this. It's all carbon. Organic chemistry is. I shouldn't say all carbon. It's all molecules that have carbon in the center. Because you can have other elements involved. You're always going to have hydrogens involved, like all these are simple hydrocarbons. The naming system of organic molecules is different from other systems that we've learned. Like you learn in Chem 1, mono, di, tri, that kind of thing. Well, in chemistry, when there's one carbon, we use the prefix meth. And everybody these days is thinking, oh, Walter White, right? He makes meth. How cool. That's methamphetamine. Those molecules are pretty big and complicated. We'll probably not have time to talk about that kind of thing. Meth is the prefix for one, and then we have F, like ethanol. We all have heard of ethanol, I think. Pro is the prefix for three carbons in a row, like this thing is called propane. We've heard of propane before for our grills when we use our gas grills. Butane is in lighters. And then the rest of the prefixes go in the same prefixes as we're used to. I think these are Latin prefixes, pent, hex, hept, oct, that kind of thing. As you look through these, the third column there, the ones that I call saturated hydrocarbons, we'll talk about what saturated means soon. for a pattern. A pattern to how many C's to how many H's? I'm going to ask you that in a moment. We've got some people in here that are writing stuff. I want to pause to be patient while you write. So if you're watching this on the video, bear with me because we'll be waiting for. And go ahead, if you guys are writing notes, then continue. But the folks that are watching, they'll just have to know, hey, we've got to wait for people to write stuff down. It's totally fine. Brian behind the camera too. Thank you, Brian, for doing this for us.
You're welcome.
Maybe if you're watching, you're benefiting because you had to miss the lesson today. You can bring Brian cookies tomorrow. He's nice enough to sacrifice his own note taking so that he can help others. Thank you very much.
Yeah, no problem.
You've seen the term saturated before. In organic chemistry, the term saturated, it means that all the carbons have single bonds to them. Now, you hear in the news about saturated fats, unsaturated oils, things like that. That is the same definition. They're fats. Fats are just real long molecules. There's 18 carbons, 16 carbons in a row, and then there's a little bit going on at the end of the molecule that we'll talk about before we're done with this chapter. But yeah, a saturated fat is one that has all single bonded carbons. Unsaturated fats have some double bonds or triple bonds, usually not triple bonds though, it's double bonds along the main chain of the molecule. That's what saturated means. So when we're dealing with very simple molecules like this, we can still use the term saturated. Just know that the term saturated means all single bond. Well, why did they use that word? Why saturated? What does that mean? Well, that means that if you've got all carbons that are single bonded to one another, then there's the maximum number of hydrogens on the molecule. If you have double bonds in there, you can't have as many hydrogens attached to it. And we'll see on the next slide what the hydrogen has to do with it. But I asked you at the beginning to find a pattern in these formulas. Does anybody recognize a pattern? Do you? What is it?
2x plus 2.
What does X represent?
Number of carbons.
Yes, very nice. So the standard and general formula is Cx, however many carbons you have. What is the number of hydrogens? 2x plus 2, right. So H2x plus 2. And sometimes you're going to see that I've used that later on in this presentation. I'll use the variable n, but it's the same thing. So saturated hydrocarbons are always going to have that general formula, Cx H2x plus 2. All right, can we move along? You've heard of a lot of these compounds too. You've heard of methane, I'm sure. Methane is what we use in our Bunsen burners in here. It's in natural gas. It's the big ingredient in natural gas, methane. Propane and butane you have experience with. Down here, octane, we know octane is gasoline. Gasoline's got a whole lot of compounds in it, but if gasoline was pure octane, it would get very high. Octane's got a huge amount of energy that you get out of it. We don't use pure octane. Yes. Okay, now this slide I'm going to ask you not to write anything from. I just want you to take a look at it and just as an introduction to why carbon. What is it about carbon that we designed this, not we really designed, but there is this whole whole huge branch of chemistry. Organic chemistry is all about carbon. Well, what is it about carbon? The fact that carbon has 4 unpaired electrons, 4 sites that it can bond with, and it will always make 4 bonds. That's one thing. Yesterday we were talking about lots of different molecules, not necessarily carbon molecules. We saw things with lone pairs and, you know, sometimes double bonds, sometimes single bonds only. In organic chemistry, the structures are really easy to write. All you have to remember is that carbon always gets 4 bonds. Now, they don't necessarily have to be single bonds. They could be, you know, some combination of single, double, or triple. But as long as every carbon in the molecule has 4 bonds attached to it, then you probably have done it right. You're going to find that oxygen always uses 2 bonds because oxygen's already got 2 lone pairs on it. In organic chemistry, oxygen's always going to have 2 bonds. It might be 2 single bonds, it might be 1 double bond, but oxygen's going to get 2. Nitrogen always gets 3 bonds, like that. But at the center of the molecule is always carbon. Carbon is, it's usually going to be bonded to other carbons in this, what I call parent chain. And then sometimes there can be things that are branching off of the parent chain. Almost always, around the outside of an organic molecule, there's going to be hydrogens. Hydrogen is convenient, it's only got 1 electron, can make 1 bond only. So we'll never see hydrogen in the middle of any molecule, but it usually will be used to wrap around the outside of the molecule, making 1 bond to the carbons. Okay. So yeah, this is what we came up with before. The alkanes are the name of the simplest of the organic molecules. They have only carbons and hydrogens, and therefore they're called hydrocarbons. And the alkanes are all single bonds, so they're saturated. Unsaturated compounds are alkenes and alkynes. Alkenes are molecules that have a double bond somewhere, and then alkynes have a triple bond somewhere. That sound is the chemistry fairies sprinkling their chemistry dust on you. You can't see them, but that's what they're doing. Do you feel it?
I'm feeling smart.
Yeah, I mean, do you just feel the knowledge soaking in with that dust? How does it look in the video? I mean, I know I've got all the lights out so we can see the board. Can you see okay?
Yeah, you can see the board.
Okay.
Okay.
You should go to the game.
You're being funny. Good.
I won't see it till tonight.
Oh, well, yeah. Make sure you download it on your phone and take it to the game. So at the bottom, I've got a couple of structures of molecules that we would consider substituted molecules. Rather than having just carbons and hydrogens, there can be other types of either groups of atoms or single atoms that can be branching off. This would be the case where a carbon, there could be 2 hydrogens on it, but it's only got 1, where instead of another hydrogen, it's got an oxygen attached to it. This is a type of compound called an alcohol. You've heard of those. This is a type of substituted hydrocarbon where all of the elements are carbons and hydrogens, but they're not all making one long chain. There are some carbons that are branched off of the main chain. These are called methyl groups because each chain, or each branch I should say, has 1 carbon coming off of it. And the prefix for 1 carbon is meth. Remember we saw that on the first slide. So there's a methyl group and there's another methyl group. If you have a chain of 2, or I'm sorry, I said that again, a branch of 2 carbons coming off, that would be an ethyl group. Now you see that we have different ways